What if inertia, the reason things seem to stay still, is not just a mysterious force pulling or pushing objects, but rather a fundamental feature of the universe's energy structure? In the energy filament theory, inertia is not just a label we assign to objects to describe their resistance to movement, but a real consequence of the energy sea that surrounds us. This energy sea creates pathways, or tension slopes, that guide everything in the universe, and the objects that move along these paths are simply following the left resistant routes. Changing the movement of an object requires it to pay the cost of altering the energy pathways it follows. And that's why inertia feels so resistant. It's not a passive force that is applied from outside. It's an inherent property of the universe's fabric. To understand this better, let's imagine a sled sliding down a snowy slope. Initially, the snow is loose and uneven, and the sled struggles to slide smoothly. But after several runs, the snow compresses and a smooth, straight track forms. This track is now the easiest, most natural path for the sled to follow. If you suddenly ask the sled to turn at the middle of the slope, it's not just changing direction, it has to overcome the resistance from the path it's already carved. This resistance, this extra effort required to change direction, is inertia in action. The sled doesn't just want to stay in one place. It wants to continue down the smooth, left-resistant path that has already been formed. Now, let's relate this idea to something more familiar: walking. When you walk, each step is like a small adjustment you're making to the world around you. Your body, bones, muscles, and even your breath work in perfect harmony, carving out invisible pathways that make walking feel effortless. But when you suddenly stop or make a sharp turn, all those tiny rhythms of your body and surroundings need to adjust. The discomfort or the feeling that you're being pushed by some unseen force is your body resisting the established pattern. It's a similar process to what happens when an object moves through the energy sea. It resists straying from its established rhythm. To illustrate this further, think about a spinning top. When you give it a twist, you're creating a circular pathway for the energy around it. As long as the top faces no major disturbances, it will continue spinning along its established path, because it's following the energy sea's last resistance route. However, if the top encounters an obstacle or a force trying to stop it, the resistance it faces is due to the energy sea trying to maintain the path it has already established. This is inertia in action, making sure that the object doesn't stray from the pattern that's been created for it. The reason inertia seems so stubborn is because it's not just the object you're trying to change. You're trying to change the underlying energy pathways that the object follows. The energy sea has etched these pathways deeply, and changing them requires a significant amount of energy, which is why inertia is so difficult to overcome. In essence, inertia is not a force in and of itself, but a consequence of the underlying tension slopes that exist within the energy sea. These slopes guide objects along their most natural and energy-efficient paths. When you try to change an object's movement, you're asking the energy sea to shift its paths, which results in resistance. This resistance is the cost of making a change. It's not the object being stubborn or lazy. It's the universe's energy sea doing what it's designed to do, resisting changes to its deeply ingrained patterns. Next time, we will explore another interesting question. Is inertia a true force or simply a feature of the way the universe's energy works? Tap follow, share it on New Physics, Clear Universe.